Hello, and welcome back to the Inside Java podcast, a podcast about everything Java brought to you directly from the team at Oracle that builds Java. My name is Chad Arimura. My guest today is Mikael Vidstedt, Director of JVM Engineering. Mikael, you're like a regular on the show. Welcome back.
Thank you very much for having me. It's always a pleasure.
So today we are talking about JDK 16. There's so much to get to. I don't even know where to start. This is the 7th release of the 6-month release cadence. How are you feeling about everything from an engineering perspective?
That many releases already, yeah. It's pretty crazy when you think about it. A few, years ago now, we used to have releases every, 2-3 years, and that felt hectic every once in a while. Now the releases are happening so often that one of the biggest challenges is actually remembering what went into which release which year. But yeah, no, this new release cadence of ours is actually working really well for us. In the past, there used to be all this, what I normally say is like proactively stressed up work of trying to plan what was going to happen 3 years into the future. And obviously we had a tendency to pick plan our releases according to the most important feature. And that was obviously, in many cases at least, the most complicated one as well, the most complex with the most dependencies. So instead of what we have now, we had all this work of, making sure, trying to practically make sure that we delivered on time and all of that. And then what we did, a few years ago now, is just turn that model completely upside down and start doing these 6-month releases, and we deliver functionality when it's ready instead. I can tell you that a lot of people, myself included, are sleeping so much better.
I've heard some anecdotes that oftentimes the team doesn't even really notice a release. It just kind of happens, and that's that.
That's absolutely right. I think it's actually the beauty of it. Sort of in the past, we used to have all this, the hectic work at the very tail end of tying all the strings together. And now it really is true, like what you say. What we try to do instead is to make sure that mainline at any given point is super stable and that we can ship it any day we want to. And what that means is that the ramp down the last few weeks before we release, development especially is not really on board anymore. We've moved on and we're working on the next release already. So it is a really good place to be.
Right. Very cool. Well, it gives us a lot to talk about too, because every 6 months we've got a ton of great content. So we
That's right.
should probably just dive right in, starting with JEP 396. Strongly encapsulate JDK internals by default. This feels like a big one that we should talk about. What should developers look out for in terms of avoiding issues moving into 16 with this one?
Yes, this is a good one. So a number of releases ago, starting JDK 9, we introduced the module system. And one of the things that allows us to do is to better encapsulate what is really in the end the internal APIs, things that are only supposed to be used inside of the JDK. But before the module system was introduced, those things, we couldn't really hide them in a good way. The only way to sort of tell that they were internal was by their package name, more or less. And with the module system, we now have the option of more clearly separating or isolating or encapsulating all those APIs. So a lot of the sort of the work that has gone on is to realize in the end that a lot of people do depend on these internal APIs. It's just a fact. They were accessible, so therefore people find them and use them. So looking at what is actually being used out there and finding good alternatives for them. And that is something that we've spent a lot of time doing over the last few releases. So it's been true for smallish things like base 64 encoding. We've done a lot of work in projects like Panama, for example, finding alternatives for some of the functionality that in the end we realize is useful, but where the internal APIs are probably not the best way of surfacing things. So what is happening now with JEP 396 in JDK 16 is that the default is being flipped. The default in the past has been to warn about uses of internal APIs. And now we're more actively sort of blocking that. There are still ways that you can get access to this. There's a command line option you can add to open the APIs up again, but the default is being changed. And I should also say, just for completeness, that there are still a few APIs, and very specifically SunMISC Unsafe, one of our old friends, that we are not changing the default for. So that is still going to be surfaced in the same way. So we're looking at still providing an alternative for that going forward, but there is no good alternative yet, so that's still work in progress.
Interesting. So the reason that you don't turn it on by default for SunMISC Unsafe is because there's no great alternative for presumably the many people who are actually using it out there.
That's right. And especially this unsafe is many different things, but one of the things that it does provide is sort of a raw way to access data in memory. And this is something that the Panama project is actually looking into. So finding alternative, better APIs that are safer and more performant and all of that to provide the same kind of functionality. But we don't feel like we're quite ready for that yet.
Right. Okay. And just to be clear, this is locking down the JDK internal APIs that most people probably shouldn't be using anyways because they were never designed for external use for various reasons. The main one being that they may change and people may not even realize that. So ultimately, this is a good change overall.
That's exactly right. So we're hoping that with the new alternatives that we've introduced, that is a better way forward for people. And, obviously those new alternatives will be supported in a way that the internal APIs weren't. It also allows us more flexibility in evolving the platform. So instead of, being locked down and, not risking maybe changing what is in the end an internal API, we now have more freedom to move the platform forward in a faster way.
Right. JEP 395, moving right along, records is becoming a standard feature. We have an entire episode on this for the Inside Java podcast. So I just want to mention that there's a lot of excitement around it and it's becoming a standard feature. So go check out the episode with Gavin Bierman. So I'll link to that in the show notes.
Right. You have the same problem we have with releases then, remembering which episode with what was discussed in. I just want to mention quickly that records to me is one of those like cool things that we've done to simplify just the way you write and think about Java code in general. So, instead of having to type out all the getters and setters or, getters specifically, I guess, and field names and all of that, it's like very compact and nice right now. So very, very happy to see records go feature complete already.
Yeah, that's awesome. And I've seen actually another plug for the release cadence. I've seen that a number of frameworks and libraries out there are actually already supporting records internally, which means that they're sticking with the latest releases. And we can continue to see community adoption of the latest releases. I remember early on in the release cadence change, people were saying, nobody will ever be able to keep up. And in fact, that's not the case. A lot of people are now working in the latest versions into their own deployment pipelines, the early access build. So wow, there's just such a galvanization around this release cadence. That's great to see.
That is awesome. Yeah.
JEP 392, packaging tool. So this one is coming out of the incubation stage. I want to talk about JPackage as like part of this change in the way application delivery model is changing. Can you talk a little bit about that?
Yes. So in the past, what we typically saw with Java and many other applications was that there was a sort of a system JRE or JDK, whatever, that you installed on the system itself. And then the application was separate from that. So you could in your application you relied on there already being a version of Java on the system where you were going to install and run the application. That is very much changing now. We're seeing that both on the client side and also in sort of the let's say the enterprise or system software side as well. So with Docker images and all of that, you're sort of expected to bring all the dependencies together with your application. And so what we've done with the JDK is to sort of adapt to that over time, introduce functionality and make it work well in those kinds of environments. One of the things that came with the module system in JDK 9 is the JLink tool. And what that allows you to do is to build custom JREs. So you can download the JDK, and given that you know that only a small subset, let's say, of the functionality in the JDK is actually used by your application, you can custom make a JRE, a runtime that only includes the functionality and the dependencies you need, really. This is useful for reducing the size of the JDK, especially if you build Docker images and things like that. You can bring it down from I think it's like 300 megs or so, the JDK is, down to a fraction of it. So you can easily get it down to 150 by just using JLink. It cuts it in half. And if you tailor make things on top of that, it will reduce the size even more. Now, before I forget, I should mention that your application does not need to be modularized to use JLink. You can take an old ClassPath legacy app and run JLink and still leverage that functionality. And it also provides some help or improvements when it comes to startup time and performance, things like that. Now, with JLink, you still end up with something that looks and smells very much like sort of the legacy JDK. It's a file tree with, a bin directory and things like that. And what we realized is that in the end, what you probably want is something that is very much more operating system native. So what the packaging tool does is to allow you to take those artifacts that JLink spits out, or for that sake in normal JDK if you start there, and produce something that is packaged and provides artifacts that are operating system native. So for example, it's an RPM, or it's a Debian package, or an installer on Windows, or whatever makes sense, right? So it's sort of taking that whole deployment chain and taking the last step in providing a full, complete model for it.
And I think we're seeing sort of a sea change in the way applications are being delivered. As you mentioned, previously there was this concept of having a runtime in an application as separate artifacts, and you could just deploy new code and it would, choose the runtime that was on that machine. But that's increasingly going away in place of this like App Store model.
That's right.
And so the packaging tool, if I'm hearing you correctly, can package up native executables for Java applications and make them sort of deliverable through this App Store model.
That's exactly right.
Cool. That's really
exactly
cool.
Right.
Let's push on. Now, here's one that I love talking about because it's just, it's pretty complex, but breaking it down, it's also really, really cool. The Vector API, JEP 338.
Yes.
We have a whole podcast episode on it, but I definitely want to cover it quickly here. And I don't know, quickly is probably the wrong term. But so the Vector API is about expressing vector computations that compile at runtime across optimal vector hardware instructions. Do you want to talk about that? And can you talk a little bit about maybe, again, some of the trends that are pushing the need for the Vector API?
The first thing I'll say is that we've leveraged vector instructions in CPUs for a long time. So I'm not sure exactly when the order vectorization optimizations were introduced in the C2 JIT compiler in the hotspot VM. But they've been there for a long time. So if you just write normal Java code and you run it, chances are that in many cases C2, the JIT compiler, will just automatically vectorize and leverage those instructions for you. That said, there are cases where in the end C2 is, it's really hard to sort of reverse engineer everything and understand all the patterns that Java code can, like all the ways that Java code can look and smell. So one of the ways that we've realized that we need to do this is to surface some more primitives to sort of the Java level. And that one of those ways is through the Vector API. So you can think of it sort of as a way to surface the instructions, but not the instructions directly. We still have an API where we abstract the underlying implementation. And in the end, this is not something that we're expecting the average Java developer to ever, hopefully in a way, have to use directly, but rather as sort of a building block for building frameworks and libraries on top of, right? Now, why would you want this? Well, it does turn out that a lot of what we do in the world right now, video processing, image recognition, sound processing, machine learning, right? All of those things are in the end just big computations, and they're big parallel computations. So a lot of just matrix multiplications, that sort of low-level thing. That is exactly what the Vector API sort of helps out with. It's surfacing these primitives that helps you implement the computations in a performance. You get sort of predictable performance. You don't have to rely on the C2 or, for that sake, JIT compiler figuring it out for you. Instead, you express it in a way that is sort of guaranteed to always vectorize nicely.
And so we're talking about the Vector API, and you also mentioned machine learning. So my mind turns to Project Panama, which it looks like Panama's got quite a bit coming in this release as well. So we have JEP 393, Foreign Memory Access API, and 389 Foreign Linker API. Both are incubators. Foreign Memory Access API is in the third incubator. Do you want to talk a bit about those two JEPs?
Yes, I'd love to. This is actually one of the things that excites me a lot, because I used to work on Project Panama. Like, I had my fingers deep in the Panama implementation. This is, 4 or 5 years ago now, I think. It's been going on for a while. The background here goes something along the lines of, we obviously have this really great Java runtime, and it has all the APIs and functionality that you can think of, right? But there are still cases where we know that there are native libraries or things that are sort of happening on, let's say, the native side. Native, when I say that here, I mean sort of you can think of it as the C++ side of things, let's say, or for that sake, other runtimes or languages that aren't Java. There are ways of accessing that today. So there is an API called JNI, or an interface called JNI, and that effectively is a way of reaching out to and calling C++ or native methods in general. Now, the challenge with JNI is that in order to actually call out to those methods, you need to go through a whole cycle of complicated steps. And JNI itself turns out to be really complex. There are few people in the world who get it right. I'm certainly not one of them. With the foreign memory API stuff that we've done on the Panama side, we are actually making that so much more straightforward. So instead of having to go through all of those complicated steps, instead what we have now is a way of really just in native Java, or I shouldn't say native here, in pure Java, in just Java normal code, something that looks and smells and acts very much like normal Java, you can directly call the native methods, other libraries, and leverage that functionality without having to write a single line of C++ code or compile things using GCC or whatever. Now, what that allows us to do is to leverage a lot of the existing libraries for example, machine learning, right? So we know that there are people who have spent a lot of time optimizing, computation processes, things that have to do with machine learning or linear algebra packages, that sort of thing. And instead of having to re-implement all of that, we can now instead leverage them in a very natural way from Java. So that's sort of what Panama and the foreign API stuff brings to the table. And I'm very happy to see that it's made all this progress and is now, it's still incubating. But that said, we're getting really close to having something that is working well for us.
I didn't know that was that was one of your babies for a while.
Yeah. No, so one of the things that you need to do efficiently, and you need to get it to work, and you then need to do it efficiently, is sort of the bridging stuff that normally people have to implement again manually in C or C++. And I was involved in doing the first version of that down call thing, right? So you automatically at runtime weave the functionality, generate the code that calls out from Java into the native library. Lots of cool stuff. I had a lot of fun with that.
So I learned along the way, a lot of people think when they think machine learning and data science, they think, oh, well, Python does such a great job of that. But I realized along the way that Python actually does a pretty good job of wrapping the native code that actually does most of the heavy lifting. And so part of what I like to say about Panama is we're really bridging the gap to what Python is doing today in many of those areas.
That's exactly right. Yes, and this is sort of the same TensorFlow libraries and all of that is something that we're hoping that we can surface in a very natural and friendly way on the Java level as well, much like it's already done on the Python side. Yeah.
Super cool. Were you in Stockholm at the time when you were working on that project?
No, I had already moved to the US. So this is shortly before I took on the role I have now. Now I'm a manager who still likes to do coding and stuff on the side, but like my main role is a manager. And this was just before I took on that role. Yeah.
Your pointy head is sticking out up here.
You bet. Yeah.
Is it a hat or is his hair? I forget.
Yeah, or beard. Yeah, or a combination.
A combination of those two. Yeah. Moving right along. So who would have thought that we were going to do a whirlwind tour of all of the major projects? JAP 390 is something coming out of the Valhalla project, warnings for value-based classes. Give the audience a primer on Valhalla.
So Valhalla is another one of those projects that has been going on for quite a while. I'm actually not entirely sure when we officially kicked it off, but it's probably more than 5 years. I'm pretty sure it was more than 5 years. And in the end, what we're trying to do there is to leverage the fact that a lot of data in today's world and in general is sort of immutable. You create it, you don't actually mutate it. And if you do, the challenge we have right now with the growing number of CPUs, cores and all of that is consistency and making sure that the data is updated in a consistent manner. So what Valhalla is doing is sort of exploring, introducing something that this has changed its name over the years. And I'm actually not sure what we called it this specific week. It used to be value types. Then we had inline classes or inline types. Looks like maybe it's value-based classes now. Don't get emotionally attached to a specific name. It may still change. But in either case, what that allows us to do is to more freely put the data where we feel it's more efficient. Right now, the promise that the memory model and the Java language gives you, or the runtime gives you, is that there's one copy and only one copy of a specific object. It has identities, you can locate it, and it needs to be consistent, right? So even if you access it from multiple threads and all of that, it's still, we need to provide the illusion of there only being one single object. But that is very challenging to get to perform well, especially across these multi-core environments. So Valhalla is sort of loosening that by introducing a concept where we don't need to keep the identity of the box around. So if you put values in, let's say you have a point, right? Then that's an X and a Y coordinate. We still need to preserve the X and Y values, but we don't need to preserve the identity of the point object as a whole. So if we want to put those fields, the X and Y fields, on the stack or in the CPU register or pass it around in some other way, we sort of give the VM the freedom to do that. This is all sort of long-term and coming. So what JEP 390 does specifically is to take a piece of Valhalla and sort of deliver it incrementally, right? So instead of waiting and doing everything at once, we see that the long-term roadmap here is that some of the JDK classes specifically will actually in some way, shape, or form at some point become value-based. And what that means is that if today you're relying on their identity, then you may have to rethink. So, for example, today, taking a very concrete example, string. String is immutable, sort of. You can't change the characters of a string once you've created it. But if you ask a string for its identity, using hash code, for example, identity hash code, I should say, then you will get a very specific value, and you will get that value every single time. And you can also do double equals if it's the same string object, right, that you find in two different places. You can compare it using double equals. That may not work going forward because, again, we want to loosen up sort of the identity piece a bit here. Now, this is all a long way of saying, and what I actually want to highlight about this is a lot of the projects we have are long running. But what we try to do is to find ways of incrementally delivering value, or for that sake, if we find that there are things that we want to do early on to give people sort of a heads up that things are changing, then this is a perfect and canonical example of that.
So I guess you could say this is incremental progress on the road to Valhalla.
Ah, yes, love the pun. Yes, that's exactly what it is.
So
how long did you think about that, Chad?
Well, I'm not going to lie, I wrote it down. I had to write that one down. It was too good to pass up. I've been on the team, I think, for almost 2 years now. So almost the entire time of the new release cadence. But I often think to myself, how the heck did you guys do this before the release cadence? Because thinking about Valhalla, for example, or Panama, like, can you imagine I'm sure you can imagine, if you were to say, gosh, we really want to deliver Valhalla in the next release. You would have to kind of figure out how to cram all of these things into a single release. Now you can do something like warnings for value-based classes and kind of give this, like you said, an incremental change to give the world a heads up that this is the direction that we're heading as part of a larger strategy, which is going to have a ton of benefit down the road, but doesn't need to be delivered because we're still kind of figuring out how it's ultimately going to look like.
Yeah, no, I would go one step further and say I'm not sure we could have done Valhalla in the old regime or the old model, right? It's an amazingly complicated project. I can't remember, somebody came up with a number when it's like Valhalla is in the order of like 10 PhDs or maybe it's 20. It doesn't really matter, right? It's really complicated. And there's a reason why we've spent 5 years working on it, and we'll spend more time going forward. And that's because in the end, it's important for us to get it right and make sure that it feels natural once we deliver it. And what that means for us concretely is that we do need to explore many different options and design ideas in parallel. And even if they feel stupid from the start, right, we still need to go through that process because maybe they still end up being, there's some kind of value there and we learn from it, right? So Valhalla, in the end, if we do this well, the only thing you may see is a single keyword added on the Java level, or maybe not even that, but you still get all of this cool value from the rest of the platform, the increased performance and things like that. So yeah, no, it's interesting stuff.
Well, you heard it here first, folks. That's the promise.
That's the promise.
That's the promise.
Don't hold me to it.
We'll look back to this episode. That's the thing about podcasting and blogging. It's there forever in your own words.
Oh my God.
Actually, no, blogging you can change. Podcasting is harder.
Yes, right.
Okay, so I have a couple more here. I do want to talk about ZGC, concurrent thread stack processing, because ZGC, or Z garbage collector, is getting better and better. JEPS 376, let's talk about that.
Yes, so 376, the concurrent thread stack processing, is one of those things that nobody will really care about when it comes to the implementation. The only way it surfaces is that things are faster. You don't need to update your Java code. You don't need to do anything. Only thing is, run with ZGC and performance will go up. That's basically the premise. Specifically, what we've done with ZGC, or the Z garbage collector, is to implement a garbage collector that does not scale its pause times, or where the pause times are not getting longer just because the heap is bigger. So quite the opposite. We're keeping all the pauses to there's in the end they're going to be a fixed low value, right? So the goal for the initial delivery a couple of releases ago, and I'm already forgetting which release that was, maybe 14. The initial promise was to keep the pause times below 10 milliseconds, no matter the size of the heap. And with the work we're doing right now, our goal is to bring that below 1 millisecond.
Wow.
And specifically what JEPS 376 does is to address the last sort of remaining source of pause times or latency in the VM. The last thing that scaled with something, and in this case it was thread stack processing. So now we have a really good foundation to build on. ZGC is already blazingly fast, and we keep working on improvements on top of that going forward. So keep your eyes and ears open.
Awesome. Yeah. And ZGC is a standard feature of the JDK now. So definitely an option for applications that use large heaps and want to keep consistent low pause times. Definitely take a look at it today. We do have an episode on ZGC. I will also put that in the show notes. We also have an episode on both the foreign memory APIs and foreign linker APIs, so I will put that in the show notes. We've been active here at the Inside Java podcast. Let's see. Now, what I learned actually when talking to Marcus Gronlund a few weeks ago about JFR is that there's actually a bunch of stuff that's coming in this release for Flight Recorder, but there are no JEPs created for them. So let's talk a little bit about those. And it sounds like it's around remote streaming and I forget. Remind me.
Event throttling.
Event
is one of the
throttling.
other big ones we worked on. Yes. So to start with, JFR is short for JDK Flight Recorder, and in a nutshell, that is a framework. You should go listen to the podcast, obviously, for all the great details here. But it's sort of an event framework that we built into the runtime itself. It has extremely low overhead. It's meant for use in production, and it can provide you with all of these insights into what's going on inside of the VM and the runtime as a whole. Anything from how garbage collection is working for you, which methods are being compiled, I/O events, security, library-related things. So it's a very sort of broad use case, and we've worked on this for a long time and delivered the first sort of GA version of it a few releases ago. So we have a good foundation now. What we did in JDK 16, and again, this wasn't covered by JEPS specifically, but the first one being the event throttling thing. So in the end here, the JFR functionality is really good at capturing data. And one of the things it actually does so well is to capture data that the amount of data tends to be, in some cases, a problem. We're simply generating too much of it. And so one of the things we worked on was the event throttling mechanism. And what that effectively allows you to do is to, instead of capturing every single event of a certain kind, you can sort of sample or only pick a few of them and sort of focus on what's important. Chances are that if you generate a lot of data and a lot of the events are the same, then just picking a few randomly, you'll still get a relatively representative picture of what's going on, right? So this does bring down the amount of data that we collect and therefore the overhead for some of the extreme cases, let's say. And the other thing we worked on was remote streaming over JMX. So it has always been the case with JFR that you can get all of this data sort of locally. If you are logged into a machine, you run your Java process, you can spit out the JFR data locally on disk and then consume it that way. But obviously more and more of the workloads are moving into some kind of network environment, maybe Docker, maybe something else, where you have processes running somewhere else, and you still have an interest in getting to, like, turning on JFR, letting it record things in the background, and then once you want to know more, you want to extract that data. And one of the obvious APIs that we have for accessing data remotely when it comes to the Java runtime is JMX. So why not, right? In JDK 16, we have now introduced functionality which allows you to extract and act on, I should also say, events on a remote machine, so over the network.
Is there anything else in particular about JDK 16 that you want to cover? Anything you want to mention that we may have missed?
Just on a high level, I still hear people be worried about picking up new Java versions, and there's still all this, the worry that we have changed things, that it's hard to adopt new releases and all of that. It may be easier than you think, and it probably actually, I will say at this point, is easier than you think. For some amount of time there, one of the challenges was that common libraries that people or applications typically depend on were not yet up to date and weren't keeping up. And I think what we've seen over the years is that has certainly changed. So a lot of the libraries actually come out with support even before we go GA with the corresponding JDK release, right? So chances are that things are A, working really well out of the box, and B, that you actually get a lot of the benefit of all the work that we've done on improving the platform over the years, both in terms of functionality and improved language functionality on that side, but also on performance or cost savings, that sort of thing in general. So give it a try. You might like it.
Awesome. Yeah. And I think that is a great message to end on, because it's also one that we are going to talk about in the keynote. So on the day that we drop this podcast, it would have been that day that we also talk about it. And we've got a list of libraries and frameworks for the ecosystem who worked in the early access builds of JDK 16 into their CI/CD pipelines. And so we're ready to go on day one. Super cool. Sweet. Well, you know the drill. Since this is the Inside Java podcast, we want to talk about an inside look into the life of Mikael Vidstedt and what a typical day looks like. And by the way, since you've been on here before, we can now see how your life has changed since the last episode.
Yes. Is this a pass-fail sort of thing where if I don't reply the same thing, it's like I'm out of here and I'll never be able to return?
No, we'll do a diff on it and see what's changed in 6 months.
That's right. So Michael's life is a good one. It may be obvious from, if you now listen to this podcast, or for that sake heard me talk before, I'm deeply passionate about the Java technology. I love the people I work with. So waking up every morning, I cannot stress this enough, look forward to working on just doing what I do on a daily basis, more or less. And what that typically involves is me getting a cup of coffee. I am a coffee drinker, guilty as charged. And I do want the Swedish sort of strong, like flavorful version of coffee, right? It needs to have lots of caffeine in it and taste. So I do that. I skim through my emails. I'm a heavily dependent on Slack sort of user. As a matter of fact, I should probably measure this someday, like how much time I actually spend on Slack. But I like to think that one of my key values as a person in this organization is just A, keeping track of what's going on, and more importantly, B, spreading the information I have and making sure that if I see two people talking about roughly the same thing, they should probably know about each other. So connecting people, I guess. And then I do the normal management stuff of sitting in meetings, talking to people, which I do enjoy a lot. As a matter of fact, I can't wait for COVID to be over, so get out and meet people. But actually, what I try to do, even though I'm a manager, is stay technical. So I do spend a lot of time staying keeping myself up to date on what's going on in the world as a whole, what we are working on in terms of projects and features. But also, one of my favorite areas is actually improving on our internal infrastructure. So our build and test systems, making sure that things work. I've been looking at various ports. I was involved in making sure that the Linux AR64 work at Oracle, that we started building and testing those binaries. And more recently, I've looked at the Apple Silicon port as well.
Very cool. Well, Mikael, thanks again for taking the time to be on yet another episode of Inside Java Podcast.
My pleasure. Always happy to be here, and don't hesitate to invite me in the future as well.